For example 7, we'll look at a Laplace transform of a whole combination of different functions. To start with, we'll apply the linearity of the Laplace transform, which are the properties 1a and 1b from the second page of the handout, to break up this sum into separate Laplace transforms and also pull out a couple of constants. So we'll have 20 times the Laplace transform of e to the minus 3t plus 7 times the Laplace transform of t minus the Laplace transform of 9 plus the Laplace transform of t squared times e to the minus 3t. Now we can work with each of these separately, and we've already done almost all the work for this. So remember from example 1, we had that a Laplace transform of an e to the at was equal to 1 over s minus a. In this case, a is negative 3, so this is 1 over s minus negative 3, plus 7 times Laplace transform of t. And from example 2, we saw that the Laplace transform of t was 1 over s squared. And then also from example 2, we saw that the Laplace transform of a constant was equal to that constant over s. So now this is a minus 9 over s. And finally, this one's a little bit tricky. If we look back at page 2, we had property 2, which was what was called the shift property. I'm going to write it down here at the bottom of the page, just so that we have it in front of us. And the shift property said that a Laplace transform of e to the at times a function of t would be equal to an f, big F, of s minus a, where big F is the Laplace transform of the little f. And the idea here is we're going to find that Laplace transform of the little f. Normally we'd think of that as a function of s, but then we're going to replace s with s minus a, which takes this function and shifts it a units to the right. So in this particular case, the little f of t that we're thinking about, we've got an f of t equal to t squared, and then we have an e to the as where a is equal to negative 3. And so here the f of s would be the Laplace transform of t squared as a function of s. And again, the Laplace transform of t squared from the previous example was 2 over s cubed. So that's the f of s. Then when we shift, when we do f of s minus a, we'll be looking at f of s minus negative 3, so f of s plus 3, which would be 2 over s plus 3 cubed. And so this Laplace transform is simply going to be, take the Laplace transform of t squared, which is 2 over s cubed, but then shift it 3 units, shift it doing the f of s plus 3, so rather than s, we'll have 2 over s plus 3 cubed. And so we have 20 over s plus 3 plus 7 over s squared minus 9 over s plus 2 over s plus 3 cubed. And that completes the example.